Today we have a 2015 MacBook Air that does not power on. This is an 820000165 board. It's already been disassembled from the case. And this one, customer says, it just suddenly shut off one day and now it doesn't work. So let's go ahead and plug in the fan and see if we actually have a no power issue. And then start checking a few things. So we have our DCM board plugged in. It will not give us a green light in the charger because there's no no I/O cable plugged in, and we do need those. So the very first rail I check on this board is PP-Bus G3 hot. So we're going to check PP-Bus G3 hot on the system side of the fuse for a couple reasons. So we'll get into that. So PP-Bus G3 hot is 0 volts on the system side of the fuse. I always check system side of the fuse because that will tell us, one, if the fuse is blown, and if the rail is missing. So that's 0 volts, and the other side of the fuse is 8.58 volts. So our fuse actually blew for some reason. So we probably have a short on the system side of PP-Bus G3 hot. So let's go over to diode mode. Let's unplug our adapter, and let's check for a short. And what do you know? We have we actually have a dead short to ground, so 0.2 ohm short to ground on PP-Bus G3 hot. So most likely this is going to be a shorted tantalum cap. So what we're going to go ahead and do is we are going to inject voltage to that fuse. We're going to take some thermal images and go from there and see which capacitor is shorted. It's probably going to be a simple repair, luckily. So let's go ahead and jump right into that. Alright, let's go ahead and put some solder on this side of the fuse. One mistake I see is people will solder the wire to this side of the fuse. You can't do that when the fuse is blown. It's very common for this fuse to blow when one of these capacitors shorts. So we're going to solder to this side of the fuse. We're just going to tin it. And then we're going to go ahead and grab our wire right here. I'm going to turn off our power supply for now because I don't want it to burn just yet. Like that. That is soldered. Let's go ahead and get our thermal imager on screen. Okay, we have our thermal imager on screen. We're going to go ahead and hit the power supply on button. That's about 3 volts and 5 amps. And let's see what gets hot. Right there. See that? Look at that cap. Alright, we know our short is in this area right here. It's probably one of these caps. I'm guessing it's that middle one with that little marking on the top. So what I'm going to do is go ahead and hit the power supply again and then use a little alcohol to pinpoint it. The thermal imager really does cut down on a lot of time finding that. Like, I don't want to be putting alcohol in every area of the board to find the short. You can just localize it and then use alcohol. The resolution of this thermal imager is 80 by 60. So it's certainly not the best, but it certainly does do the job well. Alright, power supply is on. It doesn't want to pull current right now. Let me try a different ground screw. There we go. Alright, which one is it? Is it this one? Alright, it is going to be this one. So see how long the alcohol takes to evaporate on here, or on here, or on that one. It is much quicker on that one than any of these. So that's another quick test that we can do. Same with MOSFETs, they're fine. So this cap is our suspect. Okay, let's go ahead and take off this cap. We have our hot air station set to 400 degrees or 430 degrees. It's heating up. I have a little small tip on here because I was doing something precision, so might take a little bit longer, but it'll work. Come on, melt. There we go. That is off. While that's off, we're going to go ahead and check for a short again, just to double check that our short is gone. And we are now at 500 something. Now open line. There's no more short left. So we have solved our problem. Double check again on the fuse. And that is open line to ground. So we have no issues there. Let's go ahead and grab another cap. Where are they here? AV7. I want to put down a flux that's suitable to wet lead free, so my go-to for that is going to be NC560. And that is soldered. Let's go ahead and do our fuse now, because remember that fuse blew, which is not so rare when this particular failure happens, but this fuse will not blow if the board is like internally shorting to ground or anything, so kind of impressive in a way. Would think a board internally shorting in its layers would pull more current, but guess not. It's okay if the sticker on the Wi-Fi card melts a little bit. It's not a concern. Melt, little fuse, melt. Almost. There we go. That is off. Okay, we have our new fuse right here. Gonna put down just a tiny bit of flux. We don't really need too much, and I don't ultrasonic these because there's no real need to. It wasn't liquid damaged or anything, so I try and use as little as possible. And this is done. Let's go ahead and give it a minute to cool down. Actually, I want to touch up this side a little bit. It's not bad, but I like to see it smoother. There. Perfect. Let's go ahead and clean this up a little bit. And the board should now be cool enough that we can go ahead and test it. Let's plug in the fan. So here's our fan right here, fan connector. Plugged in. Alright, let's plug in our charger and see if we get fan spin. So charger is plugged in. And that is a spinning fan, so this is most likely fixed. Let's go ahead and put this in the enclosure and see if it boots into an OS. Okay, we have our board back in the enclosure, and as you can see, this is booted into an OS. So this one is fixed. To review, we had a short on PP-BEST G3 hot that was caused by a tantalum capacitor. Replaced it, replaced the blown fuse on PP-BEST G3 hot, and this is fixed. So hope this helps you solve your problem.